On October 21st, a massive solar storm slammed into 3I/ATLAS while it was hidden behind the sun. Many thought that was the end, or proof of something artificial. But when it reappeared, still glowing and stable, scientists were stunned. No alien engines, no mystery tech, just pure comet physics proving its resilience in the harshest solar storm yet. So what really happened out there? Let's dive right in. When 3I/ATLAS disappeared behind the sun, most astronomers expected silence. Nothing could survive that close to a raging solar storm, especially not an interstellar object made of fragile ice and dust. But then something unexpected happened. Days later, faint signals started trickling in. NASA's Punch mission caught a weak, steady glow right where 3I/ATLAS was supposed to be. It hadn't broken apart, it hadn't vanished. Somehow it was still there, alive, glowing faintly, as if nothing had happened. And that was the moment the theories exploded. Did it survive because of physics, or because of something we still don't understand? On October 21st, 2025, the sun erupted. A massive coronal mass ejection, 1 billion tons of plasma traveling faster than a bullet, blasted out from active region 4246. Most of it missed Earth, but the shock wave swept across the inner solar system. Right in its path was 3I/ATLAS, racing toward its closest approach to the sun. No spacecraft were there to record the encounter directly, but space weather models showed perfect alignment. Within 3 days, the solar shock front would have slammed into the comet's environment head-on. Under normal conditions, that's a death sentence. Solar wind tears comets apart, stripping away their tails, crushing their plasma bubbles, and scattering dust into nothingness. But not this time. When the glare finally faded, the comet reappeared, steady, dim, but unmistakably alive. It shouldn't have made it, yet it did. For scientists, this wasn't proof of alien technology. It was proof of how extraordinary nature can be when pushed to the edge. The answer lies in the numbers. JPL's latest orbit model revealed subtle, non-gravitational accelerations, tiny shifts caused by outgassing jets from the comet's surface. These are measured as A1 and A2 parameters. A 1 is the push directly away from the sun. A 2, a sideways drift in the orbital plane. For 3I/ATLAS, they were about 1.7 times 10 to the minus 6 and 7 times 10 to the minus 7 AU per day squared, perfectly normal for an active comet. If this were an artificial object, the acceleration would be directional, calculated, deliberate. But this one was chaotic, organic, driven by sunlight warming the nucleus, releasing vapor, and pushing the comet just slightly off course. When these effects were included, the observed and predicted positions matched beautifully. In other words, no mystery engine, no secret control. Just thermal jets and physics doing their work exactly as expected. Still, the question remains. How could it look so stable after the storm? To understand that, we need to look deeper. Not at the comet's motion, but at what's happening around it. Dust grains near 3I/ATLAS are constantly bombarded by high-energy particles and ultraviolet light. Each tiny grain builds up electric charge until it reaches a breaking point. And then it explodes. These microbursts don't shatter the comet. They make it shimmer. Each tiny explosion fragments a particle into smaller pieces, increasing the surface area and scattering more sunlight. That's why the comet can suddenly brighten or flicker. Not because something powered on, but because nature itself is erupting on a microscopic scale. ESA's Rosetta mission saw the same thing at Comet 67P. Within hours of a solar storm, its coma changed shape entirely. What we're seeing with 3I/ATLAS isn't new. It's just happening on a far grander stage. To grasp what happened during that solar storm, we need to talk about plasma, the invisible charged sea surrounding every active comet. When sunlight hits a comet, it ionizes gas and dust, creating a cloud of charged particles. The solar wind slams into it, shaping it like a sculptor working with invisible tools. Magnetic fields bend, twist, and sometimes snap. When the October 21st CME arrived, that invisible structure must have gone wild. Fields compressed, the bow shock surged, and the plasma bubble inflated like a balloon in a hurricane. At Comet 67P, Rosetta once measured this kind of event. The local magnetic field jumped from 50 to 300 nanotesla within hours. That's not a minor fluctuation. It's like turning a gentle wind into a magnetic wall. Now imagine that happening to 3I/ATLAS, an interstellar object that's never felt our sun's fury before. Its plasma shield likely pulsed, cracked, and rebuilt itself within a single day. And through all that chaos, the nucleus endured. That's not science fiction. That's cosmic resilience. For almost a week, no one on Earth could see it. 3I/ATLAS was hidden behind the sun, beyond every ground telescope's reach. That blackout became the perfect stage for imagination. Some claimed it changed trajectory. Others whispered about intelligent maneuvering. But space observatories, Punch, Stereo, and Solar Orbiter, never lost sight completely. Their images showed faint, consistent light exactly where the models predicted. No sudden jumps, no turns, no signals, just a comet, surviving quietly while the internet screamed about aliens. And when it re-emerged on October 29th, still shining around magnitude 9.5, every scientist watching knew one thing: nature had just put on a show. So why did it live through something that should have destroyed it? Geometry, timing, and luck. At its closest approach, 3I/ATLAS was about 1.44 astronomical units from the Sun, far enough to avoid total vaporization, close enough to trigger violent outgassing. The CME's trajectory skimmed past the comet, hitting its outer plasma layer rather than its solid core. That glancing blow compressed the coma instead of erasing it, a shock that briefly made it brighter, not dimmer. It's a rare alignment, but not impossible, just nature being precise in its chaos. As the comet moved away, more observations rolled in. Ground telescopes confirmed its nucleus is small, somewhere between 500 meters and 1 kilometer wide. Its tail remains faint, barely visible. Every model, every fit, every brightness estimate points to the same conclusion. 3I/ATLAS behaves exactly like a comet should. Its orbit deviation? Explained. Its flickers? Measured. Its plasma storm? Predicted. Science doesn't have to kill the mystery. It clarifies it. And yet the internet loves the idea that it might be more, because mystery feels better than math. But what 3I/ATLAS shows us is something far more profound. That pure physics, sunlight, plasma, ice, and dust can produce moments that feel intelligent. It doesn't take alien technology to create wonder. It just takes a cosmic storm, a few thousand volts of solar energy, and a comet strong enough to survive it. That's the kind of story worth telling. Because it's true. As November unfolds, 3I/ATLAS is climbing out of the sun's glare, slowly revealing itself in the dawn sky. It's faint but steady. Each day it moves a little farther from the sun, a little closer to us, giving astronomers another chance to track its next chapter. By mid-November, it will be visible again to amateur observers with good telescopes. By December 19th, it will reach its closest approach to Earth, about 1.8 astronomical units away. A perfect window for new data, new spectra, new discoveries. And by early January, when it lines up with Jupiter, Mars, and Venus, it'll once again draw the world's eyes upward, not because it's alien, but because it's alive. The story of 3I/ATLAS is not just a story of survival. It's a lesson in how nature plays with extremes, and how human curiosity reacts when the line between chaos and intelligence blurs. Behind the noise, behind the viral headlines, there's something deeper. The reminder that every strange thing we see in space still follows laws, the same laws that built the stars, shaped the planets, and now illuminated this icy traveler from another world. It didn't survive because it was built to. It survived because it was meant to break, and didn't. That's not alien. That's the elegance of physics. So in the end, 3I/ATLAS didn't prove alien technology. It proved something even more extraordinary, that raw nature can survive where logic says it shouldn't. It faced a billion-ton solar storm, vanished behind the sun, and came back glowing. No engines, no signals, just the silent strength of cosmic physics. But here's the question that keeps scientists awake. If one interstellar object can endure this, how many others are already out there, crossing our system right now, unseen? What we're witnessing isn't science fiction. It's the frontier of reality itself. And this is just one story in a much bigger cosmic drama still unfolding. If you found this fascinating, hit like. Drop your thoughts in the comments. What do you think 3I/ATLAS really is? And subscribe to Galactic Breaking News for the next deep dive into the mysteries waiting beyond the sun. The next discovery might change everything. Again, a mysterious video swept across the internet, a glowing comet moving like a living thing. Millions claimed it was the first close-up of 3I/ATLAS, our interstellar visitor. But when scientists traced the footage, the truth flipped everything. It wasn't from space at all. It came from a drop of water under a microscope. A comet? No, a cell. And it fooled the world. Let's dive right in. It all began with a few seconds of video, silent, haunting, and strangely hypnotic. A glowing blue shape drifted through the blackness of space, pulsing like it was alive. People stopped scrolling. They stared. The caption said it all. New 3I/ATLAS footage just dropped. Within hours, it was everywhere. Millions watched, shared, and speculated. Was this really the first ever close-up of an interstellar object crossing our solar system? The movement looked organic, almost intelligent, as if the comet itself were breathing. But the more experts watched, the stranger it felt. The footage was too smooth, too perfect. Real telescope recordings are never like that. They flicker with noise, scattered light, and star fields frozen in the background. This one floated in a void, untouched by physics. Something wasn't right. As the clip went viral, astronomers and fact-checkers began tracing its origin. Teams from LED Stories, Reuters, and even amateur astronomers on Reddit started comparing it against public databases from NASA